Hello, this is question 13 on June 2022 Pure 2 paper. It's a vectors question. You have point O, or the origin, and they give you the position vector of 3 points, so A, B, C. P is a constant, so one of them has a P here instead of a number. And given that A, B, and C line on a straight line, find the value P. So we have our 3 points in a line, so I'm going to do a quick sketch. So we have, let's say, A, B, C. We have an origin O, and we know these vectors. So this vector here, O, A, O, B, O, C. Yeah, and I know OA is 4 minus 3, 5, so 4 minus 3, 5. OB is 0, 4, 6, and OC is minus 16, B, and 10. So these are my vectors, and we need to find P given that the 3 points are in a line. So if the 3 points are in a line, vectors A, B, and B, C, or A, B, and A, C, are going to be parallel. So the components will be proportional. So I can write the vector AB. So vector AB is going to be OB minus OA. So it's going to be OB is this one, OA is this one. So 0 minus 4 is minus 4. 4 minus minus 3 is 7. And 6 minus 5 is 1. So this is vector AB. And vector BC is going to be OC minus OB. And is OC minus OB. So minus 16 minus 0, minus 16. P minus 4. And 10 minus 6. These two vectors are parallel, which means the this is 16, not 10. The coordinates are proportional. So if you compare the coordinates that has numbers, you see that this vector is 4 times this one. So I have this one is 4 times this number, this one is 4 times this number. So this one will be 4 times this number, which means that 28 is going to be P minus 4, therefore P is 32. So all the coordinates of this vector are 4 times the coordinates of this vector. Then they say line segment OB is extended to a point D, so that CD is parallel to OA. So this line, and this is O, this line is extended to a point D, so CD is parallel to OA. So I have this line extended until it meets with a point in a line that is parallel to, I don't know, it looks very parallel, but this line and this line are parallel, yeah? And this point is B, and I can delete this bit, yeah? So this is what we have. Then they ask us find magnitude of OD. So we need to find the vector OD. There are a few ways of doing this, but well, I'm going to use one. So OD is going to be parallel to OB. So I can write OD. I can write OD as OB multiplied by a scalar. OB is this one here. So if I multiply by a lambda, for example, I will have a parallel vector. So 4 lambda, 6 lambda, OD. Then this vector is parallel to this vector. So I can write this vector CD as another scalar multiplied by OA. Yeah, so CD could be a mu, for example, multiplied by OA. OA, so for mu minus 3 mu, 5 mu, for example. Yeah, and I know that OD is going to be OC plus CD. And I'm going to substitute all that I have. So I can say that OD is going to be OC plus CD. And from here, I will be able to find the scalar. So OD is 0, 4 lambda, 6 lambda. Is going to be OC, which is minus 16. And I know the value of P, so I'm going to write 32 and 10 plus CD, which is 4 mu minus 3 mu, 5 mu. So if I compare this with these two, I have that 0 is going to be minus 16 plus 4 mu, so I can get mu from that. So I have 0 is going to be minus 16 plus 4 mu, which means that mu is 16 divided by 4, which is 4. So I have mu, and I can use this one, for example, 6 lambda, just because it has smaller numbers than the other. 6 lambda is 10 plus 20, because I have 5 times mu, and mu is 4. So lambda is going to be 5. I always would check with the last coordinate that this is correct. So 4 times 5 is 20, and this one is 32 minus 3 times 4, which is 12. Yeah, so it's correct. So that means that the vector OD, that is the one that I need to find the magnitude, is going to be 0 for lambda, 6 lambda, when lambda is 5. So my vector OD is going to be vector 0, 20, 30, yeah, or 20I plus 30j. So this is my vector, which means the magnitude, that is what I need, magnitude of OD is going to be square root of 0 squared plus 20 squared plus 30 squared, which is 10 root 13. Yeah, and this is the magnitude. Writing your answer as a fully simplified self. So we are going to leave it this way. Yeah, that's all with this question.